Today we will learn advanced graphing. Now, there is a very beautiful book called Play with Graphs. You can look into it. It's published by Arihant Publication. But there is another book which is much more interesting, I would say. It's a Russian book by Piskunov. I may get the spelling wrong, but this is the author's name and you can Google that. There are many beautiful graphing problems in both of these books, but the book by Piskunov has some very interesting locus problems as well. In advanced graphing, we will learn one technique where we use something called a pair of curves. So in Cheenta classroom, we discuss something like this, pair of curves. And we will look at one example problem to learn this concept. So this problem is from ISI Entrance, and it says that the equation, we are given an equation, maybe I can zoom in a little bit. Yeah. So we are given an equation, x square plus y square minus 2x minus 4y plus 5 is equal to 0. Now we want to know what curve is represented by this equation. What curve is represented by this equation? Now, in general, you would assume that if something like ax square plus by square, something like this is given, it could be a conic, like an ellipse or a hyperbola or a circle. And there are several standard forms of these things. But the trickier ones would involve something called pair of curves. So this will be equation of one curve multiplied by the equation of another curve. That's one case. The other case would be you could use this equation to check that it could be a null curve, which is sometimes a point. So both of these cases comes under pair of curves topic. There are many other complicated examples. We will use only this one. Okay. So what we will do is let's use this equation that's given here. Maybe I can pull this little thing off and use a different color. So we have x square minus 2x plus y square minus 2 times 2y plus, now there is a 5, so we will put a 4 here and put a 1 here. So 5 can be written as 4 plus 1. So I'll just put this here. Maybe we can just, yeah, we have this. So this is the old equation just written in a different way, and this is equal to 0. So this is x minus 1 whole square plus y minus 2 whole square equal to 0. It's a very special scenario, Why? Because notice that the sum of the two squares can never be 0 unless each of these expressions are 0 individually. This is a very powerful tool even in Math Olympiad. Sometimes you would want to make sum of a bunch of things, sum of the squares of a bunch of things equal to 0, because then you can make them individually 0. That's the only way sum of several squares can be 0. So remember this expression. This is a very powerful tool. Sum of squares can be 0 if each of them is 0. So this is if and only if. There are two f's here, by the way. So this means x is equal to 1. That means x minus 1 whole square is 0. This means x minus 1 is 0, which means x is equal to 1. And similarly, y is equal to 2. So the only point that works is 1 comma 2. So this equation, this so-called equation down here, let me pull this up. Yeah, this particular equation that we have here, x square plus y square minus 2x minus 4y plus 5 equal to 0. This particular equation has only one solution that represents just a point. Okay. There are plenty of similar problems in Cheenta classroom and in Cheenta website. Link in the description will take you there. Keep on doing great mathematics. I'll see you next time. Bye.